Hello friends, welcome to my channel Easy Education. Be smart and fresh. Come up and be tuned with me. In my previous video, we have learned about work, power and energy. Part 1. Let us go to practice some numerical examples so that the concept will be crystal clear to you. Question number 1. What is the work done by the force of 100 Newton if the displacement of the box is 40 centimeter and the angle between the force and the box is 60 degree? The work done by the force of 100 Newton. Let us write down the data. Quickly, so the forces being applied on the block, the force is 100 Newton and say the displacement of the block is 40 centimeter. Okay? And the angle is given. That is the angle between the force and the displacement. Let us know it can be pulled like this, and let us say the displacement is in this way. It is given to us as 40 centimeter. What is the angle here, guys? The angle given to us is 60 degree. Theta is basically 60 degree, right? Let us go and work out this. So what will be the important formula? We will use here work done is equal to force into displacement into cos theta. So what is the work done? Let us substitute 100 Newton into 40 centimeter into cos of 60 degree. So guys, don't forget to convert the centimeter into meter. As 100 centimeter is equal to 1 meter, therefore 40 centimeter is equal to 0.4 meter. It is basically 40 into 1 divided by 100. Therefore, work done is equal to 100 into 0.4 into cos of 60 degrees. It is very important to learn from this table. So, as you can see this table, cos 60 degree is a half. Excellent. Fantastic, guys. You already know the table. Therefore, work done is equal to 100 into 0.4 into half is equal to 20 joules. So the work done is 20, and what is the unit of the work done is joule. Okay? Don't forget unit of work done is joule. So please check answer and give like for this. Please check any mistake I have done in the calculations. Praveen Kumar got 20. Nitin has got 20. But don't forget to write joules. Okay? Unit is very important in physics. 20 joules. Excellent. Let us go towards our next question. Question number 2. A boy lifts up a box of mass 4 kg to a height of 150 centimeter. What is the work done by the boy and how much energy the box gain? Very interesting question. Mass of the box is given as 4 kg and the height is 150 centimeter, and it has lifted to the height of 150 centimeter, and it has lifted to the height of 150 centimeter. So the height here involved is 150 centimeter. Okay? What is the work done by the boy? let us use the formula Fs cos theta. So here no angle is given. Clearly it is in upward direction and the displacement is also in upward direction. So theta is 0 degree. Now guys, what is the force here? The force is basically the weight of the box. Do you agree? And that will be equal to mg and will not be the
work done will be force into displacement into cos theta. Here
let us substitute the values here. Mass is given as 4 kg. You take g.
G is 10 meter per second.
So displacement is 150 into 10 divided by 1000. Right? So it is 1.5 meter. 4 times 10 times 15 divided by 10. As simple as that, you guys. So how much work is transferred into the potential energy of the box? So it is getting converted. So answer we got is the same 60 joules. Clear? Very important concept done. So work done is getting converted into energy by the box. Awesome. Let us next have the very interesting question. Question number 3. What is the work done by the earth in moving around the sun? We can say the work done by the sun. So what is the work done when the earth moves around the sun? All you know, it is revolving around the sun. So how much work is done, guys? Work done is Fs cos theta. So what is the force involved here? Force is the gravitational pull of the sun and the earth. This is the force. What is the displacement, guys? You can see in this direction, right? Displacement is the tangent to the circle revolving by the earth. So it is perpendicular to its pull. That is radius of the circle of the earth moving. You can see what is the angle between the force and the displacement. So force is the gravitational pull of the sun and the earth. The displacement is the tangent. So it is the tangent to the circle. What is the angle between the force and the displacement? So it is 90 degree. Excellent. Angle, as you can see, is the 90 degree between the force and the displacement. What is the work done? Work done is Fs cos theta. Yes? Fs into cos of 90 degree. So what is the cos of 90 degree? You see from the table, it is 0. Fantastic. So work done will be force into displacement into 0. So work done, the answer is 0. Answer is 0 joules. No work is done. Because the force and the displacement are perpendicular to each other. Another way to think about this. The earth is moving around the earth. At the end of the year, it comes to its original position. So what is the displacement of the earth at the end of 1 year? Can you tell me, guys, what is the displacement of the earth at the end of the 1 year? The answer is 0, because the earth is coming to its initial position, comes back to the original position. You look out. The work done by the earth throughout the year is 0. Are you getting interest? Are you getting interest? Do share and recommend your friends to like and subscribe this channel. Fantastic. Cos is the trigonometric ratio of base and hypotenuse in right angle triangle. To calculate the cos values, let us go ahead for the next question. Question number 4. If the mass and the velocity is doubled, how does the kinetic energy of the body change? We are dealing with the kinetic energy here. So mass and velocity is doubled. My technique of doing this question is, first, what is the original thing, right? So what is the initial situation? This is very interesting. How is the kinetic energy of the body change? So what do you think, guys? You think to understand what is cos theta. So let us take a look at this. Remember, we are dealing with the kinetic energy here. Initial kinetic energy is equal to Ke1 is equal to half mv square. Now we can say, okay, now we can say after the change, right? So what is the new final kinetic energy? It is basically Ke2 is equal to half into bracket 2 times mass bracket close into into bracket 2 times velocity bracket close squared. So here, instead of mass, where we know the mass is doubled, we have got the substitute 2 into mass. Do you agree? And the velocity is also doubled. So instead of v, I am going to substitute 2 into v. But guys, don't forget to write 2 into v inside the bracket and then square it. That is 2 into v into bracket square of this, because it is 2 into v whole square is equal to half into double of the mass into 4 into v square is equal to half into 8 mv square. Very simple technique. Just find the ratio, right? So very important tip, guys. Just go for the ratio. That is all. Ratio is Ke2 divided by Ke1 is equal to half of is equal to half multiplied by 8 mv square divided by half into mv square is equal to 8 times. Do you see here? So the answer is going to be 8 times and not 4 times, guys. Please take a look. The ratio is 8:1. Just simplify the ratio. Ke2 by Ke1. Answer will be 8. All of you are getting 8 times. Awesome. So lot of you know how you got the answer. Same, that is 8 times. Praveen Kumar is saying 4. So some of you are still confusing. Oh, but 4 answer is not, guys. Please check. Take care of it. This half and half will cancel. This is half times 8 mv square. Be careful. Right. Awesome. We want to see the next question. Question number 5. A body of mass 2 kg is dropped from the height of 10 meter. Find the potential and kinetic energy of the body halfway down. Body has a mass of 2 kg and it is lifted from the height of 10 meter. So in physics, always try on this diagram. Okay, I will show you on sketch. So please guys, draw the diagram. Let us have a body of mass 2 kg and it is dropped from a height of 10 meter. This height is given us as a 10 meter, right? And this is the ground level. I am just sketching for you. Find the potential energy and the kinetic energy of the body. So how without means simply means height involved here is a 10 meter. So how you will do this question? Drop halfway down. The height involved is 5 meter. Are you agree? Right? Are you? So how do you solve this problem? Very interesting. Find the potential and the kinetic energy of the body halfway down. So the potential energy halfway down is very simple. Let us find the potential energy first at this point. So let us call this point number 1 and this is the point 2. Let us find the potential energy at halfway down, right? So halfway down, what will be the potential energy? Potential energy will be mgh, right? You can say the potential energy at point 2 because it is a point 2. I just multiply the numbers mass in kg. And what is the height? It is 5 meter. So if you multiply this, what you will get, guys? Halfway down. P2 is equal to mgh is equal to 2 into 10 into 5 is equal to 100 joules. Very good. I see 100. Excellent. Okay. Archana has got 100. Very good, guys. Okay. So if you multiply this, you will get 100 joules. So the potential energy we are found at halfway. So this part is over. So we have to find the kinetic energy half height down. Here halfway down. How you will find K2 at halfway down position? You know, we can go for half mv square. But the problem is, do you know the velocity? We will use the equation to find it out. I am sure I will give you the better technique from the equation of the motion. So what is the technique here? It is that where we can use the laws of conservation of energy. Okay, what is the trick here? Rather than finding the kinetic energy directly, what is energy at point 2? Right. So let us say this. Total E2 is equal to PE2 plus KE2, and total E1 is equal to PE1, because there is no kinetic energy here. So therefore it is equal to mgh1 is equal to 2 into 10 into 10 meter. Potential energy at the top is equal to 200 joules. How much kinetic energy will be halfway down? So what is the total energy at point 1? That is simply PE1, because the ball is just dropping. So here you will have at the top only the potential energy, right? No kinetic energy at top. There is only potential energy at this top. So using the law of conservation of energy, right, you can see the potential energy at point 1 is equal to PE1. So what is the total energy at the top? 200 joules. What is the total energy at point 2 P2? Basically P2 plus Ke2. Okay. So Ke2 is nothing but 100 joules, because you know energy is potential energy is 100 joules at point 2. So it is the final answer. Isn't that awesome? We have used exactly 100 joules. Excellent, guys. Next question. The velocity of the vehicle of mass 1 ton increases from 20 meter per second to 30 meter per second. Find the work done by the engine. The first very important thing in physics is to write the data first. Here mass is 1 ton. 1 ton is equal to how many kg? Because the SI unit is in kg. So can you say, guys, who can tell me 1 ton is equal to how many kg? 1000 kgs. Fantastic. So 1 ton is equal to 1000 kg. Very good, guys. Mass is 1000 kg, because 1 ton is 1000 kg, and the initial velocity is given as a 20 meter per second. Final velocity is 30 meter per second. Now find the work done by the engine, right? Because the car is moving, so what is the work done? Let us have the formula Fs cos theta. The force and displacement is given here. Now we will use the formula Fs cos theta. So what do you think, guys, here? Oh, some of you are already ready for the answer. Can you use Fs cos theta here? We can't, because we don't have force and the displacement. So the formula won't work, right? This formula will not work here. So what do you do now? Don't be panicked. It is very simple. As I said, very important theorem about work energy theorem. Work done is equal to change in kinetic energy. Meena says the work energy theorem. Excellent. So use the work energy theorem. What it says? Work done equals change in kinetic energy. We are going to apply that, right? Fs cos theta won't work. We will go for the next one by work energy theorem, right? So work done equals change in energy. It is basically work done is equal to half mv square minus half mu square. Half is common. Therefore, half into m into bracket v square minus u square. Now use the trick. A square minus b square is equal to into bracket a plus b times another bracket a minus b. Therefore, work done is equal to half into mass into v plus u in one bracket and in another bracket v minus u is equal to half into 1000 into in first bracket 30 plus 20 into in second bracket 30 minus 20 is equal to 500 into 50 into 10 is equal to 250,000 joules is equal to 250 kilojoules. This is the change in the kinetic energy, right? Okay. So very important application. Work energy theorem. Excellent. Let us another interesting question. A man of mass 50 kg runs up to this staircase in 10 seconds. If the height of each step is 20 centimeter and the number of steps is 30 steps, what is the power of the man? So can you guys try this question? So how do you calculate this? Write down the data first. Now man is running up the steps. So he goes up to height of these steps. So let us write down all this data. Mass is given 50 kg. Time is given as 10 seconds. Height of each step is 20 centimeter. And the number of steps is 30. So what is the displacement, guys, of this man? Displacement is basically 30 steps into 20 centimeter is equal to 600 centimeter. That is 6 meter. Because we have to convert it into SI unit. So 600 divided by 100 is equal to 6 meter. So what is the power of the man? We have to find out the power. It is basically the work done divided by time. What will be the work done by the man? I think energy by time, or you can take it in terms of force and displacement. And what is the energy involved in? Potential energy, right? So energy clearly involved here. mgh is the potential energy. It is increasing. So what is the force? The force is a great another way of. Well, work done is force into the height. mg into the displacement is height. Okay, guys? What do you think, guys, here? As you get the same thing. Let us go ahead. E is equal to mgh. Finally, we get the power is mgh. So let us substitute all these values. Mass is given as 50 kg.
G is 10 meter per second.
Height is 6 meter divided by the time, 10 seconds. So what is the final answer? You get 300. You have got 300. It is not in joules. It is power and not the work done or energy. That is joules per second. And that is basically watt. Be careful. Right? Unit of power. This is our final answer. Here you got. How we have solved this very simple. Let us go for next question. An electric bulb has a power of 100 watt. How much energy does it consume in a 1 hour? So what do you think, guys? So what formula will be applied? We know that the power is work by time or the energy by time. We can say that energy is power into time. Power is given as 100 watt, right? So 100 watt multiplied by 1 hour. Now what is interesting thing is you can calculate in SI unit. So let us calculate it. So how much is the 100 watt into 60 second multiplied by 1 hour? That will be is equal to 36 into 10 raised to 4 joule. Both answers are correct. One is in watt and another is in joules. I think guys the answers are correct in joules and commercial unit. So you can write the answer in kilowatt hour or joules. So please remember guys, this is the SI unit. Okay, and this is the commercial unit, kilowatt hour. Next question. The object of mass 1 kg is dropped from tower 850 meter. Draw the graph of mechanical energy versus distance from the top as the object falls down. So very interesting question. And let us say ball is dropped from the top of the tower of mass 1 kg. And we need to draw the graph of mechanical energy falls down. As the object falls down, guys, mainly think about it. As the distance from the top is increasing, right? So this is the distance from the top is increasing. How do you guys think? How is the mechanical energy of this body changing? What do you guys think? As the body is falling down, and remember the hint. Mechanical energy is potential energy and kinetic energy. Look like. How the graph will look like? Whether it will be slanting line, which way? How is the mechanical energy change as the body falls down? No change. Excellent. Law of conservation of energy, guys, very important. Using law of conservation of energy, the sum of the potential energy and the kinetic energy, which is the mechanical energy, will remain constant. And so the mechanical energy, which is basically PE plus KE, will remain constant. All we can say the mechanical energy will remain constant, right? It is being constant, the graph will be like a straight line parallel to the x-axis. There is no change. Very good. Because we are using the law of conservation of energy. Very interesting question here. Of course, the potential energy decreases and the kinetic energy increases. But if you will add them up, they will remain constant. So the graph line will be parallel to the x-axis. Because by the law of conservation of energy, energy cannot be created nor be destroyed. It changes from one form to another. So the mechanical energy of this body will remain constant. Clear? Awesome. Let us stop here. So thanks guys. Please like it, share it and subscribe it. Thank you very much.